Alright, so here trying to do a little bit more on the review. Starting with 14, an agency wants to know the opinions of Florida residents in the construction of a new road. The agency surveys 800 residents, identify the population and the sample. So, population, sample. So, the population would probably be Florida residents, and the agency surveyed 800 residents. So I would say Florida residents would be the population, and then the 800 residents that were surveyed. Okay, you want to estimate the number of students in a high school who ride the bus to school. Which sample is best? Explain why each choice is a good sample or a poor sample. So, 4 students in the hallway, all students in marching band, 50 seniors at random, 100 students at random during lunch. So, first of all, this one is bad because that is a low sample size. And very low sample size. Not nearly enough. So low sample size. The next one, all students in marching band. This one might not be representative of the whole school because it's just one particular part of the school. I don't know, maybe people in marching band. I don't know. I would say that's just not representative of everybody. So not representative of the school. Okay. 50 seniors at random. So, I mean, they're only talking about seniors who probably drive, so only seniors. So, again, probably not representative. And then 100 students at random during lunch. This would probably be the best one. So, first of all, it's random, and that's a good thing. Seems like it's probably going to be representative. Okay, if it's random during lunch, so hopefully most students are there. To estimate the average number of miles driven by U.S. Motorists each year, a researcher conducts a survey of 1,000 drivers, records the number of miles they drive in a year, and then determines the average. Identify the population and the sample. So, population and the sample. So, I'd probably say that the population, probably U.S. motorists right there. So, driven by a researcher conducts a survey of 1,000 drivers. So I would probably say the sample is the 1,000 drivers. Okay, a pitcher throws 40 fastballs in a game. A baseball analyst records a speed of 10 fastballs and finds that the mean speed is 92.4. The mean speed is a parameter or statistic. So, given that the population was the 40 fastballs and 10 fastballs were the survey, and so this is the sample, and so since this is for the sample, then it's definitely going to be a statistic because 92.4 is the average of the sample, not the population. So that's why. Okay. Let's see. The next one, you want to determine how many people in the senior class plan to study mathematics after high school. You survey every senior in your calculus class. Okay. Identify the type of sample described and determine whether your sample is biased. So, I mean, you could probably classify this as cluster, or I'd probably say a mix between cluster and convenience. I would assume that maybe cluster, you could say that there's other classes he could have picked from, so technically this is a group out of other groups that he chose. But it was a group chosen out of convenience, so I guess either works, so I'd be fine with that. But in any case, sample is definitely biased. I mean, because you're probably in a senior class where most maybe particularly enjoy calculus. They probably might have plans to do something in mathematics, maybe engineering or math or something of that sort. So they'd probably be taking math in the future. Okay, so a researcher wants to determine how many people in a city support construction of a new road connecting the high school to the north side of the city. 50 residents from each side of the city are surveyed. Identify the type of sample described and determine whether the sample is biased. So it seems like there's two groups, um, 50 residents and 50 residents from each of them. So I think this one would be stratified. So you have two different groups, and then some people from one group and some people from the other group. The other grouping survey is the cluster one, but in the cluster, everybody's surveyed. In the stratified, just some from each group are going to be surveyed. So stratified, and this sample is probably not biased. Yeah, it seems like it's been randomized on each side, and they're getting opinions from both sides, so that sounds good to me. 22. A researcher records the number of people who use a coupon when they dine at a certain restaurant. Identify the method of data collection. So, method of data collection, just to give you a list of what you can expect. So, method of data collection could be survey, observation, experiment, or simulation. And kind of just to jump back a little bit, types of sample. There's random. There's self-select. There is systematic, cluster, stratified, and there's convenience. Okay, just so you know. Okay, so in this one anyway, so a researcher records the number of people who use coupon when they dine at a certain restaurant. Identify the method of data collection. So I would assume this is not much of an experiment, a simulation, or a survey. You're just going to have to merely watch as it happens. So I would say an observation. Explain why the survey question below may be biased or otherwise introduce bias into the survey, then describe a way to correct the flaw. Do you think the city should replace the outdated police cars they are using? So, I would say this is, it does say that it is biased, but why? So, this right here, replace outdated police cars. So, outdated is definitely kind of urging a response. It's encouraging. Well, he's saying, do you think that the city should replace the outdated police cars? Well, most people are definitely going to say, well, yeah, if they're outdated, then yes, you should replace them. But so I think that would definitely give you a very biased answer. So it definitely encourages a response, a type of response. Encourages a specific response. Encourages a specific response. How can you correct the flaw? Probably remove the word outdated. So do you think the city should replace any police cars they are using? Maybe you just gotta find a different word than outdated. Do you think a city should replace older police cars? Because then they might have to provide a little bit of context as to what is older, what's more newer, stuff like that. But so probably remove the word outdated. Um, let's see. The next one, identify at least two problems with the following statistical study. Sam wants to know how much time people spend doing their homework each night. He asks three of his. Okay, well, there's one. Asks three of his friends. That's a low sample size. In his calculus class, how much time they spend on the homework the night before. So I see two problems in that already. Calculus class is who he's asking. The night before as well, he took the average and concluded that all high school students spend 3.5 hours per day on their homework. So definitely 3 is a small sample size. He's only picking people from calculus class, and he's asking from the night before. So you should probably ask people from all types of classes, and you should probably collect the data for more than just one night, because that's definitely 3.5 is probably a large average, but so you can pick from any of those problems right there. Okay, determine whether each survey question is biased or unbiased. If biased, explain the reasoning. So do you think the school needs a new gym and football field? So this is biased because it's asking two different things, new gym and football field. So if you say yes, you're saying yes to two different things. So whenever you're asking a question like this, you should only address one problem. You're addressing two different issues right here in hopes that maybe someone might be manipulating the data to say, well, they said yes. Yeah, definitely not a good question. How long have you lived at your current address? This sounds unbiased. If I wouldn't really think there'd be any bias. Yeah, I mean, someone might say that maybe how long you lived is too sensitive. I don't think it should be too sensitive. Maybe if it asked what is your current address, that's definitely probably sensitive information. But just saying how long you lived, that shouldn't be a problem. All right. Let's see. Determine whether the study is a randomized comparative experiment. If it is, describe the treatment group, the control group. If it is not, explain why not, and discuss whether the conclusions drawn from the study are valid. So, a study of 100 college and high school students compared their time spent listening to music using headphones with hearing loss. 12% of people who listen to headphones more than 1 hour per day were found to have measurable hearing loss over the course of a 3-year study. This doesn't sound experiment. Yeah, they were just observing results, it sounds like. So this is more of an observation than an experiment. They just, so they observed and recorded. What else do we need to say? So if not, explain why not, and discuss whether the conclusions drawn from the study are valid. So, they could be valid if I would say that they're probably valid. You might want to perform the observation with more groups and a couple more times, but that could be a little bit of a better observation. A restaurant manager wants to know which type of sandwich bread attracts the most repeat customers. Is the topic best investigated through an experiment or an observational study? Describe how you would design the experiment or the observational study. I think observational study would be fine here. So you could really just keep track and record what type of sandwich bread people are buying, and then just record that. So okay, for the next one, 31. A researcher wants to test the effectiveness of a sleeping pill. Identify a potential problem, if any, with the experimental design below, then describe how you can improve it. The researcher asked for 16 volunteers who have insomnia. 8 volunteers are given the sleeping pill, and the other 8 volunteers are given a placebo. record results are recorded for 1 month. So first of all, it's a small sample size, so I would say that's a problem, potential problem. You probably need to increase that sample size. Um, Maybe record it for maybe you don't maybe not have to record it for months and months, but maybe a month here and a month here and a month here, but probably replicate the experiment a little bit more. All right, next one. Determine whether each situation calls for a survey, an experiment, an observational study. Explain the reasoning. A grocery store conducts an online study in which customers are randomly selected and asked to provide feedback on their shopping experience. That sounds like a survey. Questions are being asked and they're responding. So, 34, a research group randomly chooses 100 people to participate in a study to determine whether eating blueberries reduces the risks of heart disease for adults. Sounds like you would probably do an experiment here because you'd probably want to compare a control and a treatment. So you would make a control group, people who do not eat blueberries, and then have people that do eat blueberries and compare the results. That way, if you made that an observation, you could not say that the results are valid. So I would do an experiment on that, so that you can get some randomness to it and reduce variables. For the next one, a research group randomly selects 80 college students, half of whom took a physics course in high school, and compares the grades in a college physics course. Couldn't really do an experiment on that one. So I would probably say between survey and observation, probably an observation. You can just take a look at grades and compare. Okay, Know It All Pharmaceutical Company has developed a new medicine to cure the common cold. The test is to test its effectiveness. They find lots of people with common colds. They give half the people the new medicine for 10 days. The other half of the people get no medicine at all. They get a pill that doesn't have any medicine in it, called a placebo, so that no one knows who really gets the medicine. Which group was the experimental group, and which one was the control group? So the control group is those who get the placebo. The placebo. Experimental group is the treatment, the new treatment / medicine, who actually get the medicine. So, all right. Before the Thanksgiving holiday, in a survey of 2,368 people, 85% said that they are thankful for the health of their family. So this is this last page is all about the margin of error. So 85% said that they are thankful for the health of their family. Whenever we're talking about a population percentage, so this 85% is for this group of people, but how might that be reflected in the actual population? So we'll use this as the margin of error for population will be so for population proportion, and I'm only just doing this to distinguish from whenever we're trying to find margin of error of a mean. This is margin of error for a population proportion. The margin of error is equal to plus or minus 1 divided by the square root of n. So in this case, it's going to be equal to plus or minus. It's going to be equal to plus or minus 1 divided by the square root of 2368. Okay, so we're going to do 1 second. So 1 divided by the square root of 2368, and we get 0.0205. You can give this as a percentage, so 2.05%, 2.1% if you wanted to say, that'd be fine with me. Okay, so that's our margin of error. Now it says give the interval that is likely to contain the exact percent of people who said that they are thankful for the health of their family. So we're going to take our estimation, and then we're going to add 2.05%. Just going to round up to make it a little easier, 2.1%. And then we're going to subtract the 2.1%. So whenever you do that, you're going to get somewhere between 82.9% and 87.1%. So that's your interval for the population proportion. So all I did was take the 85% that we had here and added the 2.1, the margin of error. Okay, so I'll let you guys do 41. Should be pretty similar. I'm probably just going to do one of these ones because 42 through 45 are all pretty much the same thing. So on day 2 of a study on body temperatures, 106 temperatures were taken. Suppose that we only have the first 10 temperatures to work with. So this is going to be the sample. This is presumably what they're saying the population is. So they're only using 10 for the sample, so n is equal to 10. The mean standard deviation of those 10 were, so the mean is going to be 98.44, and the standard deviation is equal to 0.3, I believe is what it's saying, yeah. So also I should use an S since it's a sample. Okay, construct a 95% confidence interval for the mean. So we're going to first find the margin of error, then we're going to find the confidence interval. So notice that in each of these, so we have a 95%, there's a 98%, and a 90%. That should not say 98%, that should be 99%. Sorry about that. Okay, so in any case, if you want to know what z-score you should use, so if you go on your z-score table to the bottom right, so here's the level of confidence, and then here's the z-value that you're going to use. So what did we say that we're using? 95% for this one. So 95% confidence level, you use a z-score 1.96. So we're going to say, let's get that down first. So z is going to be equal to 1.96. Okay, let's find the margin of error. So the margin of error for the mean, not for the population proportion. So for the mean, error is going to be equal to the z-score multiplied by your standard deviation, so in this case 0.3, divide that by the square root of n, which is 10. So if you put that into your calculator, so 1.96 times that by 0.3 and then divide that by the square root of 10, you get 0.19 as your margin of error. Now for the confidence interval, you're going to say the mean, the actual mean, so the population mean, this is referring to the mean of this 106, the actual mean should probably be somewhere between, well, you're going to need to take the 9.844 and you're going to add the error, so 0.19, and then for the lower bound you're going to have to take the 98.44 and subtract the 0.3. So you do that and you get that the mean less than or equal to both sides, we're going to say between 98.25 and 98.63. So that's your confidence interval. Okay, so you'll follow the same process that you did up there for here, although this one's a little tricky for 42 because it kind of gives you two numbers that could potentially be your value for n. But the reason why we choose 10 is because the standard deviation and the mean are taken from the 10 z-score. So essentially what we're saying is that this is the population right here. This is the sample. So that's what we're doing. In this one, it doesn't give you two values. It says, so like in the next one, in a study of 20 random selected managers, it doesn't really say that there's another one, but it just says that it just goes straight into the mean, and so on and so forth. So, and standard deviation was 20. Of the 20 scores, this is your standard deviation. Okay, so all right, so hopefully this was a good review. Let me know if you have any questions.